In this video, you will learn about how to factor using the sum and difference of perfect cubes formulas. I stress that these are two separate formulas. This involves factoring a binomial or a polynomial with two terms. Let me know if you have any questions in the comments below, and don't forget to subscribe so you don't miss out on future videos. Let's jump right in. So honestly, they're exactly the same. The only thing are the signs, right? The signs here are plus, plus, minus, plus, and the difference formula is minus plus plus. Other than that, everything is exactly the same. Okay, so but just make note that whether it's the sum or difference of perfect cubes, the signs obviously matter. Okay, so what is a perfect square? Something multiplied by itself twice. So what is a perfect cube? It's something multiplied by itself 3 times. That's what cube means. Okay, so sum obviously means addition and difference means the subtraction of perfect squares. So a perfectly good example of the sum of perfect cubes is x to the third plus 27. And simply put, it's those same a's and b's, but now we're just subtracting them. So in this particular case, a would be the the cube root of x to the third. So what times itself gives me x to the third, or x, right? X times x is x to the third. And b would be the cube root of 27. So what times itself 3 times gives me 27? 3, because 3 times 3 times 3 is 27. So if I were to do these examples, a would be x, b would be 3, but whether we're doing the sum or the difference formula, all that's going to matter are these signs. Okay, so again, a is the cube root of the first term and b is the cube root of the second term. For example. Okay, so notice this is an addition of perfect cubes. So it is going to be the plus minus plus instead of the minus plus plus. Okay, so what is a? It's the cube root of the first term. So what times itself 3 times gives us 27x to the cube? 3x, right? If we did a check, 3x times 3x times 3x gives us 27x to the third. So if you need to do a check on the side, go ahead and do that. So that is our a term. And b is the cube root of the second term. So what times itself gives me the b term. So this is a rather large number. So you can go ahead on your calculator and keep doing guess and check, right? You can try 4 times 4 times 4, or 5 times 5 times 5, 6 times 6 times 6, and so on until you reach 512. Or you can use your calculator to your advantage. So I'm going to remind you how to do that. So if you have a TI-83 or TI-84, you hit the math button, which is right next to the the apps button. And right off the bat, if you see in section number 4, you see the cube root symbol. Now you can either use your down arrow until you get to number 4 and hit enter, or you can simply just click on number 4 and it'll do it instantly. So now you have the cube root symbol and you're just going to write 512 and click enter. Okay, so the cube root of 512 is 8 because 8 times 8 times 8 gives me 512. Now, by the way, another way to do this is a cube root is the exact same thing as raising that number to the 1/3 power. So notice if I hit the caret button, which is next to the tan button, it automatically raises it to the exponent. Now, it's, as I said, cube root is the same thing as raising something to the 1/3 power. So I'm going to do 1 divided by 3. Right, so we get the same answer. So we're back on the screen, and again, from our calculator, we just found out that 8 times 8 times 8 is 512. So the cube root, oh, I meant to write a 3 there, is equal to 8. Okay, or you could have just done guess and check. Doesn't matter. So again, make a very big distinction on what A is and what B is, because it does matter which order, you do it in. Okay, so once you figure out what A and B is, the rest is really simple because it's just substitution. So the first parentheses is going to be A plus B. So if I use substitution, it'll be 3x plus 8. The second parentheses is going to be A squared, or 3x squared. Make sure to put 3x in parentheses or else you're going to get a wrong answer. Just a side note, how is this different than this? Right, on a side note here, squaring something means multiplying something by itself. So this is saying 3x times 3x. So you would get a 9x squared if you put the 3x in parentheses, versus if you do not put 3x in parentheses, this is the same thing as saying, right? Isn't this saying 3 times x squared? In other words, 3 times x times x. So either way, in this case, you get 3x squared, right? And if you put 3x in parentheses, you get 9x squared. So that's something huge. I always see that common mistake. So I always like to tell my students, whenever you make any substitution, your safe bet is just always put it in parentheses. Well, obviously the 3x plus 8, we didn't have to put in parentheses each. But hey, if it makes you feel better, you can go ahead and do them because then you can just drop them anyway. Okay, so, whoops. So now we're going to subtract it by A times B. 3x times 8 gives me 24x. And then finally, we are going to do plus B squared, or 8 times 8 is 64. Okay, so actually I'm going to erase this 3x squared here. We found out that's 9x squared. And here's my final answer. We are done. Even if this was a factor completely problem, so you would have to see if this quadratic polynomial is factorable every single time. So what people don't tell you or don't stress is every single time you do a sum or difference of cubes formula, the quadratic piece is never factorable, ever. So if this was a factor completely problem, you would be done. Okay, so now let's try a difference of cubes formula. So A is going to be the cube root of 64. So what times what times what is 64? Well, again, so you can either do the calculator shortcut, or on your calculator, you can try, okay, well, I know 3 times 3 times 3 is 27. Let me try 4 times 4 times 4, and it would work. So the cube root of 64 is 4. And the cube root of the B term, and people get tripped up because technically, you know, the x to the third is negative, that term is negative, but again, it's difference of perfect squares. So here are our perfect squares, and then we're just subtracting them. So we're really just doing the cube root of the x to the third. So what times itself 3 times gives me x to the third? X. X times x times x is x to the third. Okay, so again, note which one is A and which one is B, because it does matter. And now notice it's a very, very similar formula, but now instead of plus minus plus, it's minus plus plus. Okay, so once you, unfortunately, a lot of you guys are forced to memorize this formula, but once you do memorize it, it's really just plugging it into using substitution. Okay, so if I just substitute A minus B is the same thing as 4 minus x. And then A squared, which is 4 times 4 is 16, plus A times B, or 4 times x, which is 4x, plus B squared, which is x times x, which is x squared. And we're done. Okay, and again, if this was a factor completely problem, you would not be able to factor the quadratic part. You can try, and you're going to find out it's not factorable. Okay, so here I just reminded you, you can go ahead if you would like to take the time to write this in your notes. This is just what I was talking about before about finding cube roots on your calculator. I hope this video helped you learn how to factor using the sum and difference of perfect cubes formulas. If you are interested in other factoring methods, I'll leave the link to those videos in the description below. If you like this video, make sure to subscribe to my channel right now. That way you don't miss out on my future videos like this one. Just click on the subscribe button.